Business Statistics Unit number 10. In Unit number 10, we're going to be talking about hypothesis testing and deciding between reality and coincidence. So in this unit, we're just going to talk about theoretically about it because we haven't done the multiple regression analysis. We have done just correlation, and somehow we can calculate some of the p-values, but in the end, in the correlation where it's just two variables, it's much easier to determine this as compared to when have multiple variables. When we have multiple variables, and the p-values and some values are more relevant. So let's start to talk about it. First of all, let's talk about the research hypothesis. So the first thing that we're going to talk about is the null hypothesis. So the null hypothesis is a very simple statement that's saying that we have a theory or we have a hypothesis. We have a statement, and that statement is not true until we have sufficient evidence to prove that is true. So in this case, for example, I can say the more employees I have, the more productive the company will be. So I have to start with a null hypothesis by saying there's no correlation or there's no impact between the number of employees and the productivity. So what I have to do is collect all the number of employees. I collect all that data. Then I collect all the data that is related to the productivity. Then I run a test, and then if the test has sufficient evidence that as more employees I have, the productivity increases, then I have to accept the research hypothesis. Okay. If there's no evidence, I'm gonna say I'm gonna reject it. So in this case, I accept the null hypothesis, and then I reject the research hypothesis. So we're always talking about accepting and rejecting, which one is accepted and which one is rejected. So in this case, like I said, the research hypothesis means there's sufficient evidence, and then we will say that we accept the research hypothesis. So in this case, like I said, the hypothesis is a statement that we have to make it by mathematical means. We have to verify it, and we have to make sure that it's really true or not. Sometimes there's a connection, but it just happens by accident. So for that matter, like I said, we have accepting the null hypothesis means there's a weak conclusion, there's no significant results. So in this case, there's no sufficient evidence to say, well, we can say that there's evidence that connects these two or three variables. And then we have, like I said, reject the null hypothesis and accept the research hypothesis, which is a strong conclusion, a significant result. There's something that really connects this data. In this case here, gives us an example, and I think this is a very good example that says, like, think about of this as a legal case. In a legal case, you say the person is innocent until it's proven guilty. So saying that he's innocent, that's the first statement. They are always innocent until proven that he's guilty. The always innocent is the null hypothesis, and the he's guilty will be the research hypothesis. So in this case, we have many different ways to prove it, a lot of evidence. But like I said, sometimes that evidence is not so convincing. What happens if, for example, they find a gun just nearby the house of the murderer, but it's just nearby, it's not in his house. So in this case, that evidence is not sufficient. Or perhaps the fingerprints really don't match those ones of the gun. So you start to hesitate, and the more you hesitate, you start to think that, well, he might be innocent. So this is the case exactly with math and with probability and statistics. With statistics, sometimes you have data sets that really show very strong evidence. Like, for example, we have done on the correlation, coefficient of correlation, or R squared, is very strong. So in this case, we can say, well, that proves some evidence, and there's other variables that also are influencing. So yeah, the more we dig in, the more we see that connection. Okay, so now let's talk about p-values. In p-values here, we have to talk about the level of confidence. We haven't talked about that much, but in the end, first of all, we understand already that in a data set, the distribution is mostly well, we have to use normal distributions, and in those normal distributions there's only very small set of data that is inaccurate, so usually it's a 5% or a 10% maximum. So in this case we will say that we have a level of confidence that 95% of the data is in there, and then that's where here the p-values come in, which is if we are certainly that at 95% that the data will fall between a number and another number. So in this case, for example, I can go, my boss can say, if we increase the number of employees, will the productivity increase? So I have to say, well, there's a very interesting difference. I can say I'm 100% sure that if we increase it, then there's going to be more employees. So what happens if you fail? Your boss is going to say, so you lied to me, because last time you told me you were 100%. That if, let's say, for example, if I put 5 employees, productivity grows in 20%. So 5 to 20, that ratio, right? So I'm giving a very specific number, and that prompts to have a lot of error. So in this case, it's better to say I'm confident that between 3 and 7 employees can raise that productivity from maybe 18 to 23. So in this case, the statement has a little bit of range for variation and variability, because in the case of data sets we have that kind of variation, and that is what we usually talk about the level of confidence. I'm more confident to say that between this range and this range, this number will fall in, and it will behave in this way. And this is exactly what we do with a p-value to perform a hypothesis test. So in this case, we can set it at the 5% or more than that. Usually we work with the 95%. Professor, why 95% is a mathematical calculation, is already established like that. So don't ask me more about it. So in this case, we accept the null hypothesis. If the p is higher than 5%, that means that there's much range of mistake. Really, their numbers are not accurate. And if we have lower than 5%, that means it's closest to the reject the null hypothesis, and accept the research hypothesis means there's very little error for mistake. So in this case, the lower the value it is, the more likely we will accept the research hypothesis. This is very confusing, but and just you just need to roughly understand it. It's not, I'm not gonna go deeper into that. Then, so when we are talking about accepting and rejecting hypothesis, we have to talk about the 2 types of error. So the first one, it is the null hypothesis is true, but you reject it. So in this case, for example, I can say, well, the case shows that there's absolutely no connection to it, or the connection is very minimal, but I still decide to say, no, there is connection. So that is a very, very, very strong problem, because in the end, you're trying to say, like I go again to the case of the productivity. I increased employees, and then the productivity increases. So maybe I saw an increase in productivity maybe in 2 or 3, 4, 5%, very small percentage, rather than the 20 that I estimated. So in this case, I'll say, like, yeah, there's a connection, but this is so minimal that in the end, maybe your boss will continue to hire more and more and more employees, and in the end, because there was no really correlation, or the data really didn't show enough connection, then the productivity won't increase. So you see, this is the problem when we should accept that there's no connection, or is very minimal, so we accept the null hypothesis, and compare it to when it's very strong. So if it's very strong, yeah, we'd accept it, but in this case, like I said, because it's very, very little, we accept it. We are very positive about it, but here there's no room for positivity. We have to rely on the numbers. Okay, so we have to here in this one, we have to control the critical t value, which is, and we're going to measure it at 5, 10%, 5 or 10%, which is the normals at 90 or 95%. These are the most common ones. Level of confidence of 99%. there's no 100% because in the end we go back to probability that supposedly nothing happens 100%. So anyways, the 99% is a very strong level of confidence, but nobody uses it because that means I'm almost completely right, and that in mathematics doesn't really happen. And then we have the other two, the type error two, which is the research hypothesis is true, but you accept the null hypothesis. So in this case, there's evidence, sufficient evidence to say that there's two things connected or two or three things connected. There's a correlation, but I decide to say no, I'm not accepting it. So in this case, this is the other way around. I'm trying to say that there's no sufficient evidence, but maybe I'm being too strict with the data. And the same thing, I mean, I could have an evidence that hiring more employees leads to higher productivity. But in this case, I rejected. I had sufficient evidence that raises maybe at let's say 70%, 80% the productivity, but I still reject it, and I say like, no, I don't think there's strong connection. So I start to dig into other problems. Maybe I start to look into the diet of the employees raises productivity. So I discarded something that actually had strong connection for something that perhaps may have no connection. So in this case, we have to think about that. So in this case, like I said, we are always thinking and using the confidence level, and in the confidence level is where you have to use a number. So in this case, we use that to calculate it. Okay, very good. So now, when we're talking about this hypothesis testing in a multiple regression analysis or in a regression analysis, we have to make sure that the data is a random sample, meaning that there's no bias, because the moment that there start to be a bias or there start to be inclination to one or towards other side, then already the data starts to skew. If the data starts to be skewed, then there's no possible way of calculating it accurately. So we have to make sure that the random is the sample is random. It has no specific bias, so it also makes it approximately normal. Okay, two things that must be there. Now, in this case, we have as I mentioned earlier before, the test level or significance level. Like I was saying, in this case, we have the p-value or the critical t-value. So which in this case, we may measure it at the 5%, which is the most reasonable one. The most reasonable one is convention, is level set at 5%. It can be set at 1%, sometimes to make it very, very strict. This depends on the field that we are exploring. Some fields need a lot of accuracy, so we increase the confidence level to 99%. We go to the normal and accurate one to the 95% or the level of confidence of 90%. So that means how tight I want that result to be, so it's the most accurate. So you say, Professor, then why I don't carry out the 99% all the time if I want accuracy, more accuracy? Because in the end it's very difficult to achieve it. So most of the data varies a lot, so we are leaving that 5% to be more accurate. So this is a complicated thing. So just understand that by default mostly we use a 95% because we understand there's variability in the data, so we have to play with that a little bit so that we can have better a range rather than be completely at 100% accurate. So now we have examples of research. So in this case, for example, I want you to read this case. So in this case, we have randomly selected group of 200 people view an advertisement, and the number of people who buy the product during the next week is recorded. So in this case, we start with a null hypothesis. This advertisement has no effect, right? So if we have sufficient evidence that people is purchasing this product because of the advertising, then we will have to accept the research hypothesis. However, in this one, we have the baseline, which is the rate is known to be 93% based on an extensive past experience. So in this case, we're trying to reach a specific value, which is a 19.3%. So in this case, if the sales are higher than 19.3%, then we will accept the research hypothesis, and if not, we will reject it. Now, in this case, precisely this is what I was telling you about the 95% level of confidence. So between what number and what number is going to be that level of confidence. Maybe I'll say, well, if the number is between, let's say, 18 or 17 and 21, then I can accept that research hypothesis. But if it doesn't fall into that range, then then I'm going to accept the null hypothesis and say there's no connection between the values. So in this case, like I said, I can set it tighter to 19 to maybe 20% at the higher confidence level. But in this case, there is more likelihood that I will reject it. It's more accurate, but I will reject it more easily. So that's what we are going to do in there, right? So in this case, yeah, we have that one. We say the calculation, and again, we'll do the p-values, t-values, and see how they behave. And based on the calculation, we will accept or reject the null hypothesis. Again, this unit is very theoretical because in the end we're not calculating them, because there's many statistical processes and methods that you will have to do in order to know how to do this. So here, let's just think about it that let's just think in this unit about the hypothesis in the sense of like in your assignment, in your project, or in your pivot tables, do you have enough evidence to prove that something is connected to another thing? If we have sufficient evidence, we're collecting that evidence, we're calculating it, and then of course this could be further developed and tested by the p-values. But again, in this case, we're not gonna do it, but it could be further confirmed whether there's a connection and whether it didn't happen by chance. Okay, very good. So that's it for today's today's unit number 10, and with that we're done for the semester. Thank you so much.